Okay, today in class I thought it was a good idea to go over some of the concepts that we have been applying. We will continue with this arch building and testing hopefully later on this week. Probably Friday will be the earliest as far as the testing is concerned, but we will continue to assemble them tomorrow. But in this case, we've got this story problem to work on, and keep in mind we need to be aware of what the labels are, and once we've done that, then we can actually solve what the problem is actually asking. Okay, so in this case, as a farm cat is searching for a mouse, she pounced on a mouse with 101.40 kilograms per meter over second. Her size is approximately 13 kilograms. This all took place in, let's see here, 1.13 seconds. If 60 newtons of force was applied, okay, what was her speed when she first saw that mouse? Okay, so as you can see, we have a lot of variables and numbers to contend with, and just like every other problem we would approach, you've read it. Next thing we want you to do is utilize your formula sheet and write down the information that we actually know. And we've been doing that for quite a while. A lot of you are pretty good at that, and we want to continue that with solving this problem. So you got to keep in mind what it says is, what was her speed when she first started? Okay, so that would mean we're looking for that of an initial velocity. So when it first saw the mouse. So that's what we mean by the initial velocity. So as we look at this, let's look at some of the numbers that we do know. Okay, we see this one pops out 60 newtons. Anything measured in newtons, we know is a force. Okay, and her size, it doesn't say mass, but we'll go with 13 kilograms. Okay, and then we've got, let's see here, 101.40 kilograms dash meter over seconds. And we should have another variable. Yes, we do. And that is 1.13.
There will be an FCC reading emissions policy terminating 10. Thanks.
Okay. So notice I've just wrote the numbers down. I really haven't stated what they're for. I want you to take a couple moments to think about, well, which variable is which of those numbers are the variables and what we're actually looking for. Again, we've already said we do need to find this one. That's what the question's asking for right here. How fast was she moving when she first saw that mouse? So I want you to think about what those four numbers and what we can use them for. While I continue to do my weightlifting. Okay. So let's go ahead and start applying some of these. You might have figured out, yes, we've got a force, because that's measured in newtons. Okay, we've got kilograms here, so that's got to be a mass. And this is kilograms per meter over second, so that is a momentum. And here we've got 1.13 seconds, so yes, of course, that is a time. Now, in order to find an initial velocity, you'd have to know where that's found in a formula. And of course, that is found in your acceleration formula. So with that, there are three things that we need to know to solve for a velocity with that acceleration formula. And we only have one of those, and that is the time. Okay? Because remember, you would see acceleration equals Vf minus Vi divided by time. And in this case, the only variable we have is the time. But with this information, can we solve for any of those variables? So take a moment and look at what we have to decipher what you can possibly solve for. Got to switch hands. Okay. So again, we're looking for this variable. We want to know how fast she was moving when she saw the mouse. But we do have some information here that we can apply. There's two different ways that we can approach this problem. Let's see, the computer's not in the way. I think this needs to go down just a little bit. Okay. We've got a force and a mass, and we know that we can get an acceleration from that. That's one of the ways we can start this. We also have a momentum and a mass, okay? And with that, I want you to think about, well, what can you solve for with that given information? And I think the simplest place to start would be, well, let's go ahead and find our acceleration first, since we've got that written on top here. Because we know that any force equals the mass times the acceleration. So we've got 60 newtons equals the mass, which would be 13, and then our unknown, or A. All right. So, of course, we divide each side by 13. And that gives us approximately 4.62 meters per second squared. Dividing each side by 13, okay, that gives us 4.62? Yes, 62 meters per second squared. Okay, so now we've got this variable and we've got this one. Okay, so we're getting closer. We don't have any information on that, but we can find that final velocity. Okay? And with that, we're going to use these two variables. Of course, if we have a momentum, well then that will equal the mass times the final velocity. So in this case, we've got 101.40 equals the mass, which was given as 13, and we've got that final velocity there then. Okay, so how do we get VF by itself? And just like we would have done here to get acceleration by itself, divide each side by 13. And what a coinky dink. We did that in both of those problems. Anyway, 101.4 divided by 13, and that gives us 7.8. That is our final velocity. Again, dividing each side by 13, so our final velocity equals 7.80 meters per second. Okay, we're getting closer. We've got this variable, we've got this one. Now we just solve for this one. So we've got our initial velocity left. So let's go ahead and finish that. By using that formula. And we've got this, our acceleration. Why did I erase all of that? That really wasn't very smart, was it? 7.80 minus VI divided by our time, which is 1.13, and I want to say that was 4.62 if I remember. Yes, 4.62. Okay. So the idea behind this is to get this into a nice linear fraction, or excuse me, not a fraction, but nice linear equation from this fraction. So what we can do, and we've said this from the very first couple weeks of school, we can put this over 1, and it actually is always over 1. You're always going to get 4.62 with that. So we would cross multiply. We've seen this before from time to time. And upon doing that, 4.62 times 1.13, again, we're just cross multiplying here, these two numbers, and then those two times each other. So 4.62 times 1.13, and that gives us 5.22. But I'm going to put that, I was going to put it on the other side. I guess it really doesn't matter. 5.22. And then if we cross multiply with those two numbers, we're going to do the same thing here. 1 times any number, okay, is just going to give you 7.8. And then we've got minus VI. All right, so take a couple moments. How do we get that initial velocity by itself? Since there's a positive sign in front of this, to get it over to the other side and get that initial velocity by itself, we're going to subtract each side. Okay, and let's see here. And we subtract 5.22. Okay. And then it gives us 2.58. Upon doing so, we've got negative value on each side, but with that, that's not a problem because we can divide each side by -1, or you can multiply it by -1, and I'll let you decide what your answer is going to be. Well, I'll just tell you, I believe it's 2.58 meters per second. All right, so that is... notice that it's taken us, well, I've given you time to work on this. I look at the timestamp on the computer, and we're up to about close to a little over 12 minutes right now. So with that, again, tomorrow we'll continue working on that arch project, and we'll maybe start testing them as early as Friday. All right, that's all I have. We'll catch up to you next time.